writing equations in slope-intercept form. This equation is written in slope-intercept form where we can clearly identify the slope and the y-intercept. Our slope is our unit rate. It's the rate of change from one point on the graph to the next. So we know that from each point on the graph, which is your x and y coordinate when we input those, you're going to rise up 2 and across 3 to get to the next point. Also, the y-intercept tells us at what point are we going to cross the y-axis. Now, whenever you want to find out what point you're going to cross the y-axis, you're going to input x as 0 because the point where you're going to cross the y-axis is always x 0, and so we're going to input 0 into the equation. 0 times 2/3 is 0. 0 plus 2 is 2. So that helps us in graphing because we know that we're going to start on 2, then I'm going to use my slope up 2 across 3. So I'm going to go up 2 and across 3 to get to my next coordinate. And then I would do that again if I wanted to continue graphing. I would go up 2 across 3. If I wanted to find a coordinate on this side of the graph, I would just go down 2 and to the left 3. And you're going to create a nice straight line. Another way to find the slope is if I was given the graph and I didn't see this equation, I could find the slope by looking at this graph, marking off 2 points that I can clearly read. Then I would draw a slope triangle, which is a right triangle which connects one coordinate pair to the next. By looking at this slope triangle, I can see that I went up 2 and across 3 to get from point A to point B. I can draw other points on the graph also, and you can see that if I was to draw this point here, I also get a slope of 2/3, up 2 across 3. And this would continue with this pattern in both directions till infinity. Now, if you have a hard time finding the slope using the slope triangle, another way to do it is to, again, identify 2 nice clear points on the graph. For example, you don't want to pick like this point here or this point here because it's hard to read. Okay, so you want to pick 2 that are right on the corner. Then I'm going to write them down. Point A here is 0, 2, and point B is 3, 4. Now I can use the slope equation, which is y2 minus y1, x2 minus x1, to find the slope. So what I did is I wrote down 4 for y2, I wrote down 2 for y1, then I wrote in 3 for my x2 coordinate, and then I wrote in 0 for my x1 coordinate. 4 minus 2 is 2. 3 minus 0 is 3. So again, I connect my slope, 2/3. It's a positive slope going from left to right. Now, another way to look at an equation, not only through in the equation itself, we can look at a graph. We can also look at a table. This table describes the points in this equation. So, we will pick any numbers we want for our independent variable. Okay, so I just picked here -6, 3, and 0. The reason I picked multiples of 3 is so that I don't have to come out with fractions at the end. So when I input 6 here or -6, it's going to come out as a whole number. So what I did is I inputted -6 into the equation, and I did -6 times 2, which is -12, divided by 3 is -4. -4 plus 2 is -2. Next I have -3, and I plug that in, and I output was 0. So you can see that point right there. And then I input, again, 0 for x. 0 times 2/3 is 0. 0 plus 2 is 2. Now, let's say I didn't have that equation and I was just given this table. How could I find the equation given just the table? What I'd want to do is look for the slope, which is the change in y over the change in x. Okay, so I'm going to look here and I'm going to say, oh, this is going up by 2. On this side, we're going up by 3. So I know that my slope is 2 over 3, y over x, and I write it right there. Next, we're going to look for the y-intercept. The y-intercept, again, is where x is 0. That's where you graph right on the y-axis. And I can see here that it's 0, 2. So that means if I was to input 0 here, my out would be 2, and that's my y-intercept. So if I was just given this table and I had to write the equation of the line, I would write y equals rise 2, run 3, put the x in, plus 0, 2 is my y-intercept, so it's 2. Finally, we can put all this together and see why this would be useful in real life. So let's say we had a word problem like this one, and it says, Chris, a 2-year-old, is racing his 5-year-old brother down the sidewalk. Chris gets a head start of 2 feet, so he's already 2 feet in front of his brother. And then his rate, or his speed, is 2 feet every 3 seconds. So we want to write an equation based on this situation. Now, obviously, these are distractors. It doesn't matter how old the children are, so we're just putting that in so, you'd think about the question a little bit more. But we know that Chris is starting 2 feet ahead of his brother. So he already has a 2-foot advantage. So that's where I'm going to write my plus 2. Okay, so he's already 2 feet ahead. Now, we want to see their positions based on his rate of change. So our output is going to be their position, where they're going to be after they start the race. And we know that x is how far or how many seconds they are walking. So he walks 2 feet every 3 seconds. Okay. So we can see that we come up with the same equation that we did in the beginning. So again, if you was walking 2 feet every 3 seconds, he gets a head start of 2 feet. So after 1, after 2, after 3, we would create a graph looks like this. So again, his starting position was here. He already started at 2 feet ahead of his brother. And then we could see that as he goes, his distance is going to increase and increase and increase. Okay, and here are his points. So we can make a connection between an equation, a table, a graph, and a word problem. And this is useful, again, for graphing linear equations. And thank you for watching this video, and good luck to you.